we will finish the multiple choice, no calculated portion of the 2012 AP Calc AB exam. Okay, so let's get started. I feel like I did something very similar to this before in another year's test. This says the graph of a differentiable function f is shown here. If h of x is this guy, which the following is true? They ask about h of 6, h prime of 6, h double prime of 6, okay? So what would h of 6 be? That would be the integral from 0 to 6 f of t dt. This is f, so it's the integral from 0 to 6. That's the area under the curve. This is below the x-axis, so it'll be a negative number. So let's just say negative. So, okay, how about let's find first what h prime of x would be. H prime is just the fundamental theorem of calculus. That's f of x. So if we evaluate at x is equal to 6, that's h prime of 6. So that's h prime of 6 is f of 6. What's f of 6? That is 0. Okay. How about h double prime of x? That would be f prime of x evaluated at x equal to 6. Okay. Or h prime of 6 would be f prime of x evaluated at x is equal to 6. Okay, so what's f prime? That's the slope of the tangent line. This is some positive number at x is 6, so positive. Okay, so we found our answer. Because h of 6 is negative, it's the smallest, so we can eliminate these three. Then h prime is 0, so that would be in the middle. H double prime is positive, so that's the biggest. So 15a. That's how we do this one. Particle moves along the x-axis with its position at time t given by this guy, where a and b are constants and a is not equal to b. For which of the following values of t is the particle at rest? Well, particle is at rest when velocity is 0. So let's find the velocity, which is the derivative of position. So x prime of t is v of t. Here we need to use the product rule. So first, d second, put second, d first. So first, d second, derivative of t minus b is just 1, okay? Plus second, d first, derivative of t minus a is just 1. So we want this to be 0. So let's solve for t. 2t minus a minus b is equal to 0. So t would be a plus b over 2. When this is the time, the velocity is 0. So I believe 16 is b. Yes. Okay, that's how we do this one. Okay, we are given the graph of f, which is here. The figure above shows the graph of f. Okay, if f equals the integral from 2 to x of g of t dt, which the following could be the graph of y is g of x. Well, we know that f prime of x is g of x by the fundamental theorem of calculus. So we just want the derivative of this guy to find g, and that would be g. F prime is g. So derivative of some linear function should be a straight line, and this slope is positive, so it should be a positive straight line above the x-axis. So it looks like it would be a, okay? So these are not constants, so we can eliminate those, and then this is a positive constant, which we know that has to be the answer because the rate of change here is positive, okay? We have this difference quotient, it looks like, limit as h goes to 0, ln of 4 plus h minus ln 4 over h. Okay, so you should recognize this is the limit definition of the derivative. So what are we finding the derivative of? We're finding the derivative of log ln x, and we're evaluating it at x is equal to 4. Okay, that's what this difference quotient is. So it's just 1 over x evaluated at x is equal to 4, because 1 over x is the derivative of log. Okay, so this is just 1/4. 18 is b, as simple as that. Function f is defined by x over x plus 2. What points x, comma y on the graph of f have the property that the line tangent to f at x, comma y has slope half. So when it talks about tangent line, the slope of the tangent line, that should signal derivative. That is the derivative, right? The slope of the tangent line. So let's find the derivative of f, probably. Okay, so f prime would be, well, we got to use quotient rule here. So bottom d top, derivative of x is just 1, minus top times derivative of the bottom, which is just 1, over bottom squared. Okay, we want the points to have the property that the slope of the tangent line is half. So f prime is slope of the tangent line. We set it equal to half. Okay, so we can simplify the top. Actually, we get 2 over x plus 2 squared is equal to half. Okay? And we can even further simplify. We can divide by 2 on both sides, so we get 1 over x plus 2 squared is 1/4. So we know that we have to match the denominators, right? So x plus 2 squared is equal to 4. Okay? When does this happen? When x is equal to 2. X is equal to 0. That's the easy one. Is there another one? Because this is a quadratic. How about when, because we want, if it's negative 2 squared, that's also equal to 4. So when does that happen? That will be negative 4, right? Because negative 4 plus 2 is negative 2. Negative 2 squared gives us 4. So at x is 0 and x is negative 4, we get a slope of half. Okay? Slope of tangent line is half. The derivative is half. So what's the y coordinate? Well, we could probably just already guess that it's c, but let's confirm. When x is 0, what's the value of y? That is 0 also, right? That's confirmed. When x is negative 4, what's the value of y, or f? We get negative 4 over negative 4 plus 2, which is negative 4 divided by negative 2, which is positive 2. So we confirmed that it's c. Let f be 2x plus 1 quantity cubed. Let g be the inverse function of f. Given that f of 0 is 1, what is the value of g prime of 1? Okay, so this, I never remember the formula, so I always just derive it real quick. The inverse of a derivative of an inverse, sorry. We say that y is f inverse of x. This is how we derive it. So in other words, x is f of y. So we differentiate both sides. It'll be 1 with respect to x. 1 is equal to f prime of y dy dx. So we know that dy dx is 1 over f prime of y. Y is f inverse, so it's 1 over f prime f inverse of x. Okay? All right, so this is the formula that we probably need. So we are given that f of 0 is 1. What is g prime of 1? So g is f inverse. Okay? So we want the derivative of g at 1. So that is, so we just plug into here. Instead of y is g. So it's 1 over f prime f inverse of what is the value that we want? Of 1. Okay? What's f inverse of 1? Well, we are given that f of 0 is 1. So f inverse of 1 is 0. So we actually want 1 over f prime of 0. So what is f prime of 0? Well, okay, let's find f prime now. Let me do it up here. F prime is 3 times 2x plus 1 squared times 2. Okay, we evaluate it at x is equal to 0, because that's what we want over here. So we get, what, 6? So it should be 1/6. 20 is D, yes. Okay, so we just had to apply this formula, which I never remember, so I just derive it every time. That's how we derive it, okay? The line y equals 5 is a horizontal asymptote to the graph of which of the following functions? Okay, this is a pure algebra question in my opinion, not even calculus. Y is 5 is a horizontal asymptote for which one? Well, horizontal asymptotes, not vertical asymptotes, so you got to pay attention to that first. And I believe it would be E. Why do I know that? Well, here we can do the degree test. This is a rational function. Degrees are the same. We take the ratio of the leading coefficient. So 20 over 4, that's 5. Okay? So here we do the same thing. Degrees are the same. We take the ratio of the leading coefficients. That's 5 over -1, so it's -5. So that's not 5. So it's not that. Here, is there a horizontal asymptote? I don't think so. There's a vertical asymptote, but not a horizontal asymptote. This is just some linear line. There's no asymptotes at all. Sine 5x over x. I think this is one of those oscillation ones. So there's no asymptote. Okay? That I can think of. Okay? So it should be E. All right, and then let f be the function defined by f of x is ln x over x. What is the absolute max of f? Okay, so when we want to find absolute max, let's find the relative max min first, if there are. And then, okay, they didn't define a closed interval. So let's just take the derivative and see what's happening to f. To see if it's like always increasing, then there's no absolute max, okay? That's what I'm thinking. Hopefully that makes sense. So let's find the derivative first, and I'll recap once more. F prime would be, we can use the product rule or quotient rule. I feel like I've done this in previous tests before also. Let me do the quotient rule this time. Bottom d top minus top d bottom over bottom squared, which is 1 minus log x over x squared. Okay, so what's the absolute max of f? So let's set this equal to 0. Let's find our critical. Let's do the first derivative test, basically. So our critical points are when x is 0, because we'll be dividing by 0, and x is e, because ln e is 1. 1 minus 1 is 0, okay? Oh, shit, left my space. Okay, but we plug in some, well, okay, one is this, what's the domain of this guy? Can we plug in some value less than 0? No, we can't, because log has to be greater than 0. So we can't even plug in log of 0. Okay, so we ignore everything over there. So actually, it's okay that I drew it here coincidentally. Okay, how about some number between 0 and e? Remember, e is like 2.7. So we can plug in x is 1, for example. We get ln of 1, which is 0. So 1 on top over 1 on bottom. So the sign is positive. So it's increasing here. All right, and how about after e? Well, we plug in a huge positive number. Log would keep increasing as x increases. So we would get a negative number on top over a huge positive number, so it'll be negative. So we know that f is, since whenever f prime is positive, f is increasing. Whenever f prime is negative, f is decreasing. So f increases from 0 all the way to e. So there's actually a relative max here. And then it starts decreasing after that. So let me finish writing that. So the relative max is at x is e. What's the value though? It's asking the value. So we need f of e. What is that? That is just 1 over e. So 22 is B. Okay. P of t is the size of a population at time t, which the following differential equations describes linear growth in the size of the population. Okay, so it wants linear growth, so the rate of change should be constant. Okay? Because that would describe linear growth. Okay? So this would be, if you remember, this would be exponential growth. So it's not that. this would be even more than that. So not that. So it's one of these. So if we even just integrate all of these, it's just power, right? So this one, only this one, you get like 200t plus c, and this describes linear growth, okay? So that's A. This is one way to solve it. I also know that if it's linear growth, then the rate of change, meaning the derivative, should be a constant. So that's only this one, okay? There's different ways to think about it. Let g be given by x squared e to kx, where k is a constant. For what value of k does g have a critical point at x is 2/3? So let's find the derivative of g and set it equal to 0. That's how we find our critical points. So g prime of x is, we need to product, well, it'll be first, d second would be k e to the kx plus second times derivative of the first, that's 2x. We set it equal to 0, okay? We want x equals 2/3 to be a solution, so we can maybe plug that in even, but maybe let's see if I can factor anything to make our life easier. We can factor out x e to the kx, it looks like. Okay, so if we factor x e to kx from this first term, then we would get what? X times k, I believe. Okay, if we factor out x e to kx, we're left with 2 on the second term. Okay, so now let us plug in x's 2/3. So we get 2/3 e to the k times 2/3 and 2/3 k plus 2 is equal to 0. So the exponent e is never 0. So this can never contribute to the solution. So this is the only possible guy. So we want 2/3k plus 2 equal to 0. So we get 2/3 k is -2. So we multiply both sides by 3/2. So k would be -3. Okay, 34 is A. That's how we solve this one. Oh, actually, there's quite a few problems left. I have 4 more. Okay, let's finish this. Which of the following is a solution to the differential equation dy dx is 2 sine x with the initial condition y of pi is 1. So we can just integrate both sides. So y is the integral of 2 sine x dx, which is what? -2 cosine x plus c. They give us an initial condition, y of pi is 1. So 1 is equal to -2 cosine of pi plus c. We solve for c. That's why they give us the initial condition. So cosine of pi is -1, so we get 1 is equal to 2 plus c. c is -1. So our particular solution is -2 cosine x minus 1. 25 is E. Let g be a function with first derivative given by g prime of x is integral from 0 to x e to minus t squared dt, which the following must be true on the interval x is between 0 and 2. Okay, so this is asking about increasing, decreasing, and concavity, and even point of inflection. Okay, so maybe let's find g double prime first, so we can start looking at answers. So g double prime of x, we just use fundamental theorem calculus. That's e to minus x squared. Okay, so we can look at the concavity between x is 0 and x is 2. Well, the exponent e is always positive. I just said that in the previous problem also. So the concavity of g, because to find concavity related things, we usually take the second derivative, right? So if the second derivative is positive, it's concave up. If the second derivative is negative, the concavity is down. Okay? Hopefully that made sense. I don't know what I just said, honestly. Okay. So once again, the second derivative is related to concavity. So we know that because we just found a second derivative, this is always greater than 0. So because the exponent is always positive. So we know that's always concave up. So we can eliminate the concave downs already. Okay. About points, okay, let's leave that. Let's skip that for now for the points of inflection. Actually, they wouldn't have any points of inflection because the second derivative doesn't change sign. So actually, we can eliminate that also. So it's either A or C. Which one is it now? Is G increasing or decreasing? How does e to the minus t squared look? It looks similar to e to the minus t. So how does that look? It looks something like this. Okay, so is G increasing or decreasing? So why did I draw this? How does this help with G? Well, when we integrate from, so G prime is the area under this curve. The area is always positive. So G is always increasing. Since the derivative G prime is always positive, G is always increasing. So that's why I drew that. Okay, hopefully that made sense. This is a very conceptual problem. Okay, this looks at implicit differentiation. If x plus 2y times dy dx is equal to 2x minus y, what is the second derivative at the point 3, 0? Okay, so let's solve for dy dx first. So that would be 2x minus y over x plus 2y. Okay, let's also evaluate this at the point 3, 0, because we probably will need that when we find the second derivative. So let's just find it right now. So we get 6 minus 0 over 3 plus 0, which is 2. Okay, so we're going to use that later probably. So let's find the second derivative here. So it'll be second derivative of y with respect to x is here we need quotient rule, so it might get a little messy, but that's okay. So it'll be bottom d top would be 2 minus dy dx minus top d bottom would be 1 plus 2 dy dx over bottom squared. Okay, so now we evaluate this whole thing at 3, 0. So we get what? X plus 2y, that is just, we found up there as 3. 2 minus dy dx at 3, 0, that's 2. Minus top, which we found previously as 6. And then here we get what? 1 plus 2 times dy dx at 3, 0. So again, we use this value. So it'll be 1 plus 2 times 2, which is 1 plus 4, which is 5. Over bottom squared, which is 3 squared. Okay, so what do we get? Well, this term looks like it goes to 0. So we get minus 30 over 9, which is minus 10 over 3. 27 is A. Okay, that's how we do this one. So the trick here was we had to plug in for here 3, 0. And then that helped us solve the second derivative because there were terms that were dy dx. Okay, last problem for the no calculator portion, I believe. I think so, yeah. For t greater than or equal to 0, the position of a particle moving along the x-axis is given by here. What is the acceleration of the particle where the velocity is first equal to 0? Okay, so let's find velocity first. So that's v of t is just x prime of t, which is cosine t plus sine t. Okay, and acceleration is the derivative of velocity, which is minus sine t plus cosine t. Okay, so when the velocity is first equal to 0 for t greater than or equal to 0, so we set this equal to 0. How do we solve this? This is trig now. So where is sine t equal to negative cosine of t? Well, if you remember our unit circle, sine t is negative cosine t. So the sine of x has to be different than the sine of y. Remember, sine is y and cosine is x. So it would have to be somewhere in this quadrant or this quadrant, right? And if we're going from t greater than 0, so we'll go this way. So this would be the point. What is this point over here? That is, it should be t is 3 pi over 4. Okay, hopefully I did that correctly. So if t is 3 pi over 4, then we plug it into here. So it will be minus sine of 3 pi over 4 plus cosine 3 pi over 4. Okay, so what is that? It would be, what's sine of 3 pi over 4? That is that is plus root 2 over 2. Sorry, but there's a negative sign here, so it becomes minus. How about cosine of the same angle? That would be minus root 2 over 2. Okay, so this is just negative root 2. Answer is A. Okay, and that's it for the no calculator portion. Hopefully this has helped you out if you're studying for the AP exam or just practicing. Please like this video and please subscribe also if you haven't already. And I'll be doing the graphing calculator required portion next. So look out for that video also. So please subscribe to get notified for that.